In this lesson, we're going to look back at the first SOAP-based example, the RAND service, and use that to draw some conclusions about what's good and what's challenging about SOAP-based services. I have two summary documents among the working files. The one you're looking at now is called SOAPReview1.txt, and the companion is SOAPReview2.txt, and we'll look at that momentarily. I'm not going to read through these. I'm going to use these really as a summary of the main points that I would like to make. Let's begin with the upside. If you look at the RAND service, on the implementation side, it's almost trivial. There's a POJO class, RAND service, any name of course would do, and it's annotated as a web service. It contains operations. Those operations are any public method by default, but it's best to annotate those methods as web methods. It's good documentation, very easy to do. The really important thing is that those operations should be so-called pure functions. In other words, they should map their arguments to the return value. They should not depend upon fields shared with other operations. So for example, the RAND service has only two operations, next1 and nextn. Next1 can be called independently of nextn and vice versa. In a production-grade SOAP-based service, you would, of course, have more operations, and they might be more complicated. For example, an operation might go against a database, access other web services. All of that is perfectly fine so long as there is no interdependence among the operations. So, for example, next1 shouldn't have to assume that nextn has already been called, or vice versa. Another nice feature of pure functions is that they're thread safe because they don't work on shared storage. A good sign that you have pure functions is that your web service doesn't have any fields that might be shared among the methods. With Core Java 6 or greater, you have everything you need to do SOAP-based services. If you're using Core Java 5, I've left a URL here for you to check out. It's down here. That's the home page to get the required jar file. In the first example, on the service side we have Java, and on the client side we have Perl, and there's not a single piece of XML to be seen anyplace. The serialization to and from XML, in other words, the conversion from Java to XML on one end, and from Perl to XML on the other end, is all done automatically. It's under the hood. It's not visible to the programmer. If we need to make it visible, we could. Java has utility classes to do that. But in general, we don't want to see the XML. It's just infrastructure. Now, one question that comes up that needs addressing is, what sort of Java types are serializable? That is, what types go automatically to and from XML? And the answer is very reassuring. All of the primitive types and their wrappers, so for example, both int, the primitive, and integer, the wrapper, string, calendar, that includes date, and even object as a catch-all. You can have arrays or collections of any of these, for example, either straight arrays or array lists, and any programmer type that is reducible to the above. And that covers most of the classes that you and I might write. If there's an example of a Java type that is not covered, and the most famous example of that is the map, so for example, a hash map, it's relatively straightforward to write the serialization code yourself. And in fact, starting with Core Java 6, they have a nice little tutorial in the Java doc about how to do that. In SOAP-based services, the programmer gets to focus on the application logic, not on the serialization to and from XML, which is a tremendous boon. Now, let me look at some of the challenges for SOAP. SOAP is now under W3C control, and it's designed to be transport neutral. This is really an important point, and the reason is this. If you deliver SOAP over HTTP or HTTPS, you get automatically everything that those transport protocols offer. So, for example, reliability. If you send a SOAP message over HTTP and it fails to reach the destination, you get a notification. The system automatically will retry, typically up to about 10 times or so before failing. If you're working with HTTPS, you get data confidentiality, encryption and decryption, and so on. But if SOAP is to be transport neutral, that is, if it's to work on any protocol at all, and not necessarily HTTP or HTTPS, for example, something as basic as a named pipe in a Unix or a Windows environment, then things such as reliability and data confidentiality have to be baked into SOAP because SOAP can't rely on the underlying transport. This makes SOAP significantly more complicated. And the example I would use is WCF, the Windows Communication Foundation, which is a framework for server-oriented systems. WCF is essentially a layering on top of SOAP, and it aspires to be, and for the most part is, transport independent. For example, WCF works over UDP, it works over TCP, if you're familiar with those protocols. It also works, of course, over HTTP, but it doesn't require any specific protocol. Java, by the way, interoperates very well with WCF. Both sides have done a nice job in making sure that that happens. SOAP over HTTP, including HTTPS, is straightforward, friendly, and it brings a lot of advantages. When we turn to the client side of SOAP, we'll see even more advantages. If you move to transport neutral SOAP, you're moving into a far more complicated environment. So the examples that I'm going to use will stick with SOAP over HTTP and HTTPS.